Imagine if I were to share with you that propulsion technology for space travel is no longer confined to the realm of science fiction. Can you envision a future where spaceships will traverse the cosmos at the speed of light or possibly even faster? Scientists have uncovered a groundbreaking method 10 times faster than the speed of light, sparking anticipation for remarkable changes ahead. Welcome to SpaceVerse, where the mysteries of the cosmos unfold before your eyes. Embark on a cosmic journey with us as we delve into the latest discoveries, mind-bending theories, and awe-inspiring wonders of the universe. Get ready to expand your cosmic knowledge and venture into the boundless beauty of the SpaceVerse. Let's start. Surpassing the speed of sound and light. The Concorde, a supersonic passenger plane that completed the Paris to New York journey in a mere 3.5 hours, marked a significant milestone in aviation. Though the Concorde is now part of history, with only fighter jets maintaining supersonic speeds, humanity has progressed beyond reaching a pivotal point on our journey into space. To navigate the vast distances of the cosmos, spaceships must exceed the speed of light. Otherwise, it would take millennia to reach the nearest star system. For a considerable period, the laws of physics seem to impose limitations on the ability of humans or any matter to travel at the speed of light. The explanation is straightforward. Einstein's equations of general and special relativity assert that nothing in space can surpass the speed of light. The impediment arises because matter cannot approach such speeds. Doing so would render equations of dynamics and energy requirements obsolete. Scientists faced a significant challenge in unraveling this complex puzzle. Now, there appears to be a potential avenue to manipulate time and space, enabling the creation of a spacecraft capable of surpassing the speed of light. If you have an affinity for science fiction space movies, you're likely familiar with the real-life counterpart known as the warp drive. In this scenario, the spacecraft undergoes a momentary acceleration after which only a brilliant light is visible. Subsequently, matter vanishes into the dimensions of time and space, only to reappear anywhere in the vast cosmos. This process allows for the rapid coverage of immense distances, transforming the prospect of traveling to the farthest reaches of the universe into a tangible reality. While initially popularized for entertainment by authors like John W. Campbell and the iconic Enterprise creator Gene Roddenberry, the scientific community embraced this concept in the 1990s. Evolving beyond Einstein through a strategic approach, Einstein's theory of special relativity articulates the interchangeability of energy and mass, asserting that material objects with a non-zero rest mass cannot achieve the speed of light. This implies that theoretically, reaching the speed of light demands an infinite amount of kinetic energy. The solution to this predicament involves manipulating space around the object by folding or warping it. Warp, in this context, denotes distorting or bending space. Rather than relying on energy for thrust, the force is directed towards distorting space, creating a fold through which a spacecraft effortlessly maneuvers. Remarkably, Einstein's foundational theories in cosmology and physics remained unaffected by this innovative concept. Despite this breakthrough, two challenges persist: the generation of energy to fold space and addressing technical feasibility. In 1994, Mexican physicist Miguel Alcubierre tackled these issues, albeit at the theoretical level. Leveraging Einstein's general relativity theory during his doctoral studies at the University of Wales, Alcubierre developed a framework within the constraints of the laws of physics, paving the way for the possibility of faster-than-light travel. In practical terms, according to relativity, objects progressively gain weight as they accelerate. The logical consequence is that the increasing weight poses challenges in sustaining acceleration or elevating it to the extent required for a spacecraft to attain the speed of light. Only particles with virtually no mass, such as photons, can achieve these immense speeds. Miguel Alcubierre devised a propulsion system bearing his name. The principle is straightforward and accessible even to non-experts, creating a localized expansion of the space-time continuum behind the spacecraft and a contraction in front enables motion perceived as exceeding the speed of light by external observers within the distorted region. However, occupants within the distortion would perceive minimal effects, perhaps noticing a faint trail of light, stars whizzing by, or a subtle vibration. In a matter of moments, a warp spaceship could traverse vast distances simulating flight, or in other words, achieving faster than light travel. The Alcubierre drive can effectively expend an immense amount of energy to contract and manipulate the space-time continuum ahead of it, generating a bubble that simultaneously folds space. This bubble acts as a physical inertial system, ensuring occupants feel no actual acceleration. Despite this, the laws of physics remain consistent within the bubble, maintaining conformity both inside and outside. This innovative approach allows matter to move through space faster than light, not through conventional thrust and speed as seen in cars, airplanes, or space probes, but through a clever and unconventional trick. The universe presents unexplored possibilities. One common mistake humans tend to make is perceiving the universe as a single expanse. However, according to relativity, space-time is akin to a flat sheet that gets distorted by any object with mass. The familiar gravitational effect results from this mass influence, and the distortion of the space-time continuum prevalent across the universe manifests as gravity. Remarkably, even as you sit in front of your computer or smartphone, you are contributing, albeit minutely, to the distortion of space-time generating gravity. In this context, an intriguing question arises. Can a human intentionally contract space in front of them, creating a time fold and emerging elsewhere in space? Theoretically, this is plausible. However, in practical terms, accomplishing this would necessitate a substantial force far beyond the influence of mere weight. The Alcubierre drive introduces a bubble essential for circumventing the laws of physics externally. Yet internally, employing a propellant presents a challenge. Whether utilizing diesel, gasoline, hydrogen, or methane, the current available means lack the power required. In fact, the energy equivalent to the mass of Jupiter is indispensable based on existing knowledge. Nevertheless, a recent solution has emerged. Negative matter. This exotic substance, theoretically possessing negative mass or energy density, is believed to be the long-sought solution. Yet on closer inspection, a minor obstacle surfaces. Negative matter is not only challenging to conceptualize, but remains undiscovered to date. While its existence is suspected, conclusive proof is still lacking. So, how do we go about creating a propulsion system with something that might not even be in existence? Furthermore, if we were to identify this type of matter, the pressing question remains: how can we amass or generate a sufficient quantity of it to fuel a spacecraft? Where there's a challenge, there's a solution. Researchers remain relentless in their pursuit of warp drive technology, because its necessity is undeniable. Before delving into the latest and most ingenious concept for a practically and unequivocally feasible warp drive, let's revisit our current technological standing as humans. Brace yourselves, because the upcoming information might be disheartening for those who harbor aspirations of achieving faster than light travel. Our swiftest spacecraft. The speed of light stands as a universal physical constant at approximately 300,000 kilometers per second. In the realm of fiction, the Enterprise could transport its heroes through space and towards new adventures at a maximum warp speed, 9,000 times faster than the speed of light. As of now, our fastest spacecraft are the space probes. These probes, despite being relatively small and light, require considerable thrust to reach destinations like Jupiter, Saturn, or Venus. For instance, the Juno probe, which orbited Jupiter from 1995 to 2003, achieved a top speed of 74 kilometers per second, merely 0.02 times the speed of light. Voyager 1 took almost 35 years to exit the solar system and is now positioned over 21 billion kilometers from Earth. The Parker Solar Probe, the fastest spacecraft crafted by humans, attained speeds of up to 191 kilometers per second near the Sun. These figures underscore the limited reach of human technology in the cosmos. Even covering small distances poses significant challenges. In cosmic terms, our progress can be likened to taking a single step outside the front door. Probes launched into space employ intricate acceleration maneuvers using gravitational fields of planets to make any headway with a reasonable energy expenditure. Some probes orbit the Earth and Venus, or leverage Jupiter as an acceleration boost. Through seemingly interminable orbits, they gradually approach their destinations within the solar system over several years. Consider a scenario where your friend from the Proxima Centauri system invites you for coffee, and you find yourself having to navigate numerous circles around planets with your spaceship just to exit the solar system. Given our current technologies, it's highly unlikely that anyone would arrive in a timely fashion. Presently, planning a visit to a cosmic neighbor would entail more than 100,000 years. In this manner, our progress in the universe remains limited. If we aspire to become a space-conquering species, we must await the advent of new technologies. The genuinely achievable technology. Advancements in warp technology persistently progress. Dr. Eric Lent from the University of Göttingen recently introduced a groundbreaking approach to warp drive that overcomes the conventional challenges associated with negative matter and extensive energy requirements. In his research, Dr. Lent details how acceleration to the speed of light can be realized using existing and implementable physical properties. The crucial element lies in the utilization of solidons commonly referred to as warp bubbles. This method only relies on known positive energy densities, yet further research is necessary to ascertain its technical feasibility. While contemplation in Dresden was ongoing, another groundbreaking revelation emerged. Dr. Harold Sonny White, a former NASA specialist, identified a genuine warp bubble. Although Dr. White was initially exploring the feasibility of a warp drive at NASA, his focus shifted to the Casimir cavity observed between two closely placed metal plates. Within this cavity are natural warp bubbles, and ongoing research in this domain is financially supported by the Defense Advanced Research Projects Agency. Essentially, the task at hand involves replicating these small structures on a larger scale. Successfully achieving this could pave the way for the first authentic warp drive and open up possibilities for interstellar travel. And that's it. Thank you for joining us on this cosmic voyage through SpaceVerse. If you enjoyed exploring the mysteries of the universe with us, don't forget to like, share, and subscribe for more mind-expanding content. Until then, stay curious and keep exploring the wonders of the cosmos with SpaceVerse.